We have to complete the remaining part of network primer 2. Yesterday we have gone through the subnetting basics, subnet mask and need of subnet mask. And this subnet mask is basically used by system software to extract network ID and host ID from a given IP address. So depending on different classes of IP address, there can be some default subnet mask value. Then masking operation. So we have covered masking operation, then subnetting process, benefit of subnetting, reason behind the subnetting. Then how subnet address is created, how subnetting is created. So before subnetting, we have network ID and host ID. After subnetting, we have to borrow some of the bit from host portion. Then the borrowed bit will be treated as a subnet ID, means it will be responsible for number of subnet and number of hosts per subnet. And this is the default subnet mask bit for the class A, class B and class C, as well as how many bits can be taken from host portion in different classes. For class A, we have 1 to 22, class B 1 to 14, and class C, minimum 1 bit can be borrowed from the host portion and maximum 6 bit can be taken. So this is the default subnet mask. And this is the default subnet mask in binary format. Before subnetting, we must have some calculation in our mind that how many number of subnet is required, how many hosts is required in a particular subnet. Accordingly, we have to decide how many bits we need to borrow from host portion. And this is the shortcut method to compute the subnet mask. You can immediately calculate the decimal equivalent of the binary number. So now coming to the computing net and host, different types of subnetting example in class A and class B, class C. So yesterday we have covered this subnet mask example. Now coming to some more example. So this is the example of class C, in which we can have different number of subnets on the basis of depending on number of bits borrowed from the host portion. So this is one of the example with 192.168.0.0/27. So this /27 means 8 plus 8 plus 8 24 plus 3 bits taken from the 220 host portion. So with this 3 bit from the host portion, we will have 2 to the power 3, 8 number of subnet will be there, and remaining 5 bits are there in the host portion, which will contribute to the total number of hosts. So 2 to the power 5 minus 2, 32 minus 2, 30 hosts in each subnet. So we can take the example of this subnetting. We have given network address, and in this network address, we want to do subnetting with the help of So in the new example, we can start with 192.168.0.0, and this is our subnet mask, subnetting mask 27. So by default, because it is a class C IP address, class C, so by default, the subnet mask is /24. 24 means total 3 octets are used by default, but now we are taking additional 3 bits from the host portion. So that is why it is contributing to total /27 as a subnet mask. So new subnet mask can be written as 255.255.255.224. So how it is 224? Because 111.000.00. So 128 plus 64 plus 32. If you add this number, you will get 224. So this is the decimal equivalent of this binary number. So we have some new subnet mask 255.255.255.224. So with this subnet mask, so first we can calculate how many number of subnet will be created by borrowing 3 bits 2 to the power 3, 8 subnet will be there with this new subnet mask. And number of hosts per in each subnet will be remaining bits are 5 bits are remaining in the last octet. So 3 contributing to this and 5 for host. So 2 to the power 5 minus 2, 32 minus 2, 30 hosts per subnet. So we have total 8 subnets. So what will be the IP? What will be the address of first subnet, second subnet, third subnet? So we can have a shortcut method. You can write here 256 minus 224. So this 224 needs to be subtracted. Why 224? Because this 224 is contributing to the subnetting. It is subnet ID. So just subtract 224 from the 256. So we will get some base number. हमें एक base number मिलेगा. उस base number को तब तक add करते रहें जब तक 0 ना हो जाए. So what will be the result? 32. So 32 can be treated as base number. Again at 32, we will have 64. Again at 32, we will have 96. Again at 32, we will have 128. Again at 32, we will have 160. Then again at 32, we will have 192. Again at 224, 256. After adding 32 in 224, we will have 256. So basically 256 is nothing, but it is a 0. So 0 will be first subnet and 32 will be the second subnet, 64 will be the third subnet, 96 will be the 4, 5, 6, 7, 8. The last subnet will be 224. So we can write here first subnet, second subnet, third subnet, 4, ... 8 subnet. Network address for this subnet, broadcast IP address, DIP for this subnet. So first IP will be 192.168.0.0. Second will be 192.168.0. Because 0 cannot be taken. 0 is contributing to network portion. It is class C 192.168.0. So we have to keep this intact. We are only interested in this last octet because last octet is getting subnetted because we have taken bit from the last octet. So we will have 0.32 here. Then 0.64. I am not writing 192.168. 0.64. Then 0.96. ... Last will be 192.168.0.224. So this will be the address of last 8 octets. And so actually what we are doing before subnetting, we have a range something like this 192.168.0 to 192.168.0.255. So it is original network range with default subnet mask. So we have network address 0.0 and 0.255 broadcast IP. In between we have total 254 IP address available. This 254 IP address can be further subnetted. This large network of class C can be further subnetted into smaller subnets, which can have maximum 30 hosts per subnet. So we have actually divided this range into 8 subnets. So after dividing this, we will have something like this. So 0.0, 0.32, 0.64. Now this will be the new network address of different subnet. And what will be the broadcast IP? For the first subnet, we can easily subtract 0. Just subtract 1 from the second next subnet. So 0.32 minus 1 means 0.31. So 0.31 will be broadcast IP. For this network, 0.63. For this network, 0.97 or 95. Similarly, the last will be 192.168.0.255. Now we will have the valid IP address that can be actually assigned to the computer in the particular subnet. So the first IP of this subnet and the last IP of this subnet will be, the first IP will be 192.168.0.1 and the last IP will be 0.30. So this 30 IP address can be allocated in each subnet. Similarly, we can find out the last one. Last will have 0.225 to 0.254. 30 IP. So 30 IP in each subnet. So this is the way how we calculate the subnet mask. And after subnetting, we will have independent small network, and this small network will work independently in isolation mode. And if we connect all this subnet with the help of router and routing table, then it will be possible to make communication between different subnets. So with this subnet, we can easily apply some policy for particular subnet. For example, this subnet can be allowed for a particular services. So in this way, we have option to block a particular, to allow the, or to apply the policy for particular subnet. Now coming to classless inter-domain routing. So classless inter-domain routing is basically a method used by ISP. So when ISP allocate IP block to organization or individual, they allocate something like this. Suppose some IP address is there, 210.212.51.16/29. So basically they are providing you the network address slash with subnet mask. So with the help of this Cider notation method, one can easily calculate that what is the my IP address range and what is my default subnet mask. /29 means 255, 255, 255, 24 plus 5 bits taken from the last octet, 240. So this will be my new subnet mask as provided by ISP, and accordingly there will be some range. So my network address is 51.16, and after that, whatever IP address is there, there will be some block of IP address that will be used in my network. So why it is known as CIDR notation, classless inter-domain routing? Because there are some protocols, basically routing protocol. There are two types of routing protocol: classless routing protocol and classful routing protocol. So I am coming to this point also. So basically, the ISP use this types of notation, and it is known as class CIDR value or CIDR notation. So /8 means nothing, but it is 255.000. 255 8 bit is being used for subnet mask. 9 means 255.128. 8 bit from first octet, 1 bit from second octet. So in this way, we can have minimum /8 and maximum /30. So maximum /30 means 255, 255, 255.252. So this is the valid subnet mask range for all classes. But for some classes, for class A, this entire subnet mask value will be permitted. But for class B, we will start from /16 because minimum 2 octet is used by default subnet mask of class B. Similarly, in class C, we have minimum /24 and maximum /30. So similarly, we can perform the subnetting for different classes. So you can perform this subnetting for class A, class B, class C at your own level. तो ये आप लोग इसको कर लेंगे, प्रैक्टिस कर लेंगे. तो मैं इस टॉपिक को स्किप करता हूँ. So there are many examples are already covered Now coming to VLSM topic. So this VLSM, so actually what is happening in subnetting when we are doing subnetting, जब हम लोग subnetting करते हैं तो हमें जो भी block मिलता है, whatever block we are getting, suppose we are getting 8 number of subnet, 30 hosts in each subnet. In any example, we are getting some number of subnet, 16. For example, इस example में 16 subnet है and each subnet have 4094 number of IP address or host possible. So it is possible that the ISP or organization do not want uniform host in each subnet. Sometimes there are few number of hosts required for a particular subnet, and there might be more number of hosts required in a particular subnet. For example, a ISP can have variable number of customer in different networks. So they may require, they will require variable subnet masking. So there should be some mechanism that can allow ISP or organization to use variable subnet mask when required. So this will shape the IP address, because uniform block of IP address means if you are having 50 IP address in each block, but your one of the network is having only 20 computer. So again there is a wastage of 30 IP address is happening. So we can again save the IP address by using VLSM technique. So VLSM is also a method of pen and paper mathematical calculation, but this VLSM support must be supported by our router, our routing protocol. So VLSM allow you to apply different subnet masks to the same class of address space. VLSM divides the mask value in the middle to limit the further wastage of address. So basically, subnetting also provides the division of large network into smaller one, but it is providing the uniform block. But we want non-uniform block for our variable number of requirements. So this variable number of requirement can be fulfilled by variable length subnet masking. We can use different types of subnet mask at different place when required as required. But these types of VLSM is supported only by the protocol which have support for only by those routing protocol which have support for variable subnet mask parameter. So what is the benefit or features of VLSM? VLSM allow you to have more than one subnet mask for a given class of address, whether it is a class A address or B or C. तो यहाँ पे क्या है कि आप अपने उसी नेटवर्क एड्रेस स्पेस में, जैसे अभी हम लोगों ने एग्जांपल के तौर पे देखा था, यहाँ पे देखिए, in this network we have equal number of hosts in each subnet. 30 hosts इसमें भी है, 30 hosts, 30 hosts, 30 hosts, और सबके सबनेट मास्क कांस्टेंट है, सेम है, क्योंकि सेम सबनेट मास्क अप्लाई होगा /27 इस नेटवर्क में हर पीसी पे /27, इधर भी /27, इधर भी /27, इधर भी /27. हो सकता है कि किसी पर्टिकुलर नेटवर्क में ओनली 10 कंप्यूटर यूज हो रहे हैं, तो वहां पे आपके 20 आईपी वेस्टेज हो रहा है, और किसी नेटवर्क में आपको मोर देन 30 कंप्यूटर की जरूरत है, तो वहां पे आपको फिर दो नेटवर्क का बेनिफिट लेना चाहिए था, लेकिन वो यूनिफॉर्म सबनेटिंग में नहीं हो पा रहा, वो प्रॉब्लम VLSM में सॉल्व हो जाता है. So in VLSM, classful routing protocol. Classful protocol means classful routing protocol. For example, RIP protocol, routing information protocol version 1, IGRP do not support VLSM. So there are some routing protocol which do not have support for class for variable लेंथ सबनेट मास्किंग. VLSM सपोर्ट नहीं करते हैं, तो ऐसे प्रोटोकॉल जो VLSM सपोर्ट नहीं करते हैं उसको बोलते हैं क्लासफुल राउटिंग प्रोटोकॉल. तो RIP v1 nor IGRP routing protocol have a field for subnet information, because this routing protocol do not have a special field available for providing variable subnet mask. So it is assumed that this protocol will use the same subnet mask across all the network. तो अगर RIP प्रोटोकॉल इस राउटर पे इम्प्लीमेंट होता है तो वो ये एज्यूम कर लेता है कि सारे नेटवर्क में सेम सबनेट मास्क यूज हो रहा है, क्योंकि RIP प्रोटोकॉल में वैसा कोई ऑप्शन ही नहीं है कि हम अलग अलग नेटवर्क के लिए अलग अलग सबनेट मास्क प्रोवाइड करें, बिकॉज इट इज ए क्लासफुल राउटिंग प्रोटोकॉल. Only classless routing protocol can provide you VLSM feature. So if a router running RIP has a subnet mask of certain value /27/30, it will assume that the same subnet mask is being used in all networks. So RIP v1, IGRP, interior gateway routing protocol, these protocols are mainly responsible for dynamic routing. So there are two types of routing: static routing and dynamic routing. So static routing is configured manually. Administrator need to specify the exact routing table as per their requirement. But the same routing table can be generated, can be built with the help of dynamic routing protocol. Automatically routing table create हो सकता है. So RIP v1 and IGRP is an example of classful routing protocol. The classless routing protocol have a support for advertisement of different subnet masks in their messaging. So classless routing protocol has support for VLSM. तो VLSM वहीं पे काम करेगा जहां पे ISP classless routing protocol यूज कर रहा है. फॉर एग्जांपल BGP, Border Gateway Protocol, EIGRP Protocol, ISIS Protocol, OSPF Protocol, or RIP version 2 protocol. So these are the dynamic routing protocol which do have support for VLSM features. So they can have different subnet masks for different networks in their working mechanism. तो VLSM का बेनिफिट क्या है? VLSM provide efficient use of IP addressing in large scale network, ability to perform route summarization. So there is a route summarization term, route summarization or route aggregation, to reduce the size of routing table. More number of routing table, more number of network means more number of routing table advertisement will be propagated by router. कोई भी राउटर करता क्या है? राउटर अपने पास जो राउटिंग टेबल है या वो जिस नेटवर्क से डायरेक्टली कनेक्टेड है उसके बारे में इंफॉर्मेशन अपने नेबर राउटर को वो प्रोपगेट करता है. वो बताता है कि ये नेटवर्क मेरे से कनेक्टेड है, दूसरा वाला नेटवर्क भी मेरे से कनेक्टेड है, तो यही सेम इंफॉर्मेशन नेबर राउटर अपडेट करता है. फिर उसी तरह से कई सारे नेबर राउटर आपस में एक दूसरे को अपने अपने नेटवर्क के बारे में इंफॉर्मेशन देते हैं, उससे सारी राउटिंग टेबल क्रिएट होती है. तो अगर इस राउटिंग टेबल की साइज को रिड्यूस करनी हो, आपको पूरा डिटेल हर राउटर को सारी डिटेल बताना पड़े सबको, तो उससे क्या होगा? देयर विल बी मोर नंबर ऑफ routing update will be propagated in the network. So it will result in bandwidth consumption. It will require more CPU, more powerful router. So there can be some mechanism. For example, suppose you want to find some address of a person in a city. So you need not to know about the every location of Lucknow. Suppose you are going to Lucknow to your friend. So your friend has given only certain address, but you need not to get aware with the entire Lucknow that this place, all place need not to be noted. So you have to note some important point that just catch this train and with this train deboard at this particular station, then directly go to this network. Similarly, in routing mechanism, router need not to provide all the network detail to each and every neighbor router in the entire internet or entire network system, because it will generate lot of traffic. To reduce this traffic, we can have some options that we can summarize the summary version of routing table that this network can be combined as a single network. And after combining this network, because you are going to some place, so you need not to store information about different location in different table. First you reach to Lucknow, then in Lucknow there will be one person, he will guide you. You need not to store all the information. Similarly, a router need not to propagate all the information to each and every router in the network ecosystem. Few information can be propagated to other router. On the basis of this few information, router will reach to the main router. Then this main router will help in carrying the data to the appropriate destination. So basically, VLSM can provide route summarization or route aggregation. VLSM allow you to use more than one subnet mask for a given class of address. The two major advantage of VLSM: more efficient use of address and route summarization and aggregation. तो due to route summarization आपकी bandwidth भी सेव होगी और router पे भी overhead कम आएगा. Before VLSM, suppose this is a network topology in which there are many routers are there, and each router is having different network, but each network have equal subnet mask /26/26/26. यहाँ पे भी /26 है, यहाँ पे भी /26. और इस नेटवर्क में, this is an example of network. This is a network यहाँ पे multiple PC connected होंगे, but this network is having only two interface, 1 or 2. So here we require only 2 IP address in a particular subnet. But यहाँ पे हम ज्यादा सबनेट यूज कर रहे हैं, यहाँ पे हमारी बाकी आईपी वेस्टेज हो रही है. इस नेटवर्क में हमें सिर्फ 2 आईपी चाहिए, इस पॉइंट के लिए और इस पॉइंट के लिए. माय माउस कर्सर इज विजिबल और नॉट? So basically, this is also a network. This point-to-point network between these two routers is creating a network. So this network requires only 2 IP address. One IP address to be configured on this interface, and second IP of the same network to be configured on this interface. तो यहाँ पे जो सबनेट मास्किंग हम लोगों ने सिलेक्ट किया है, वो हमें ज्यादा more number of hosts provide कर रहा है. It means with this option, with this subnet mask, how many hosts will be created? It is a matter of calculation. Suppose it is generating 30 hosts in each subnet. It means we can use the only 2 IP address here. Remaining 28 IP address will be waste, because it will go in waste, because it cannot be applied anywhere, because there are only 2 interface where we can apply IP address. So we can have option. There should be some mechanism like VLSM which can provide the variable number of subnet masks, so that we will appropriately select the subnet mask which will provide only 2 hosts in a network for this segment. For this segment, if we have a requirement of 30 hosts, then we will accordingly choose the subnet mask. Here again, 2 hosts is required only, because there are 2 points. Similarly, this segment also require 2 points. It means these 3 segments can have a subnet mask which have 2 hosts per subnet option. So before subnetting, before VLSM, we have something like this. Here we are using equal subnet mask everywhere. After subnetting, you can have variable subnet mask. For example, here /26/26/26, but here we are using /30. यहाँ पे /30 है, यहाँ पे भी /30 है, यहाँ पे. और /30 subnet mask will provide you only 2 hosts. आपके पास कितना बच रहा है? 30 लेने का मतलब है 2 bit host के लिए है 2 to the power 2 minus 2. Only 2 IP address will be available in a particular subnet, and these 2 IP address can be assigned on this interface and in this interface. तो ये VLSM का बेनिफिट है. यहाँ पे आपको 30 का रिक्वायरमेंट है, यहाँ पे आपको 16 का रिक्वायरमेंट है. अकॉर्डिंगली this mask can be also modified. But this modification, this application is only applicable for classless routing protocol. क्लासलेस राउटिंग प्रोटोकॉल मतलब RIP, V2, BGP, ISIS, OSPF, EIGRP. These protocol can have option for variable subnet mask. So route summarization is nothing but it is a form of VLSM. So route summarization is the ability to take a bunch of contiguous network numbers in your routing table and advertise this contiguous route as a single summarized version. मतलब इतना कॉम्प्लिकेटेड नेटवर्क पूरे लखनऊ के मैप के बजाय हमने आपको लखनऊ का एक एंट्री पॉइंट बता दिया कि यू रीच टू लखनऊ, देन वी विल गाइड यू इंटरनली इन द लखनऊ रीजन. Similarly, in a routing table, this router will provide the summarized version of entire topology to their neighbor router. मतलब इस राउटर का जो भी नेबर होगा यहाँ पे उसको सिर्फ ये इनका कॉन्टिग्यूअस कंबाइंड वर्जन इसको बस बता देगा कि आपको किसी भी इस पूरे कॉन्टिग्यूअस वर्जन में पहुंचना है तो मेरे पास आ जाओ, उसके बाद मैं गाइड कर दूंगा. तो इस तरह से कुछ होता है रूट समराइजेशन. सपोज there are many networks connected to this router 1.0/26, 1.64. These are different subnets. ये क्या है? डिफरेंट सबनेट है. 1.0/26, 1.64/26, 1.128, 1.192/20. अब these are 4 different subnets. So normally without VLSM, without route summarization, this router need to provide information of each network to their neighbor router. But with summarization version, router will combine this entire network in a single summarized route 192.168.1.0/24. So all these route can be further provided in the form of 1.0/24. उसके बाद जब IP, चूंकि कम्युनिकेशन तो IP बेस्ड पे होगा, सपोज सम नेबर राउटर वांट टू सेंड ट्रैफिक टू 1.65. So 1.65 means it is a part of this. It will reach here, then router will check 1.65 is a part of this subnet, so it will forward it to the appropriate subnet. तो यहाँ पे आप देखिए ये अलग अलग टेबल की इंफॉर्मेशन नहीं पब्लिश हो रही है, सिंगल नेटवर्क की इंफॉर्मेशन विथ डिफरेंट सबनेट मास्क वैल्यू सबमिट हो रही है, क्योंकि इसी के अंदर सारे आ जाएंगे. 1.0/24 में 1.0 भी आएगा, 1.1 भी आएगा. ये तो डिफॉल्ट सबनेट मास्क जैसा ही है. So advantage of summarization of VLSM or route aggregation is that it reduces the size of routing table requiring less memory and processing power on a router. It reduces the size of routing update requiring less bandwidth. अगर बार बार हर टेबल का इंफॉर्मेशन जाएगा तो यहाँ पे बैंडविड्थ बहुत कंज्यूम होगा. अब ये छोटा सा इंफॉर्मेशन भेजने के लिए आपको बैंडविड्थ कम कंज्यूम होगा. तो बेसिकली VLSM is more advanced form of subnet masking. Again, it is a matter of your paperwork. You have to use some sheet. VLSM sheet बोलते हैं. ये VLSM sheet होता है ऐसा कुछ इस तरह से. पहले से आपके पास एक blank sheet होनी चाहिए. So before implementing VLSM, we can have this table. So this table should be ready with you. So this table means /26 means this is the standard block size. 192/27 means 224, 28 means 240. So it can have, suppose you want the host size of 62 in a particular network, then you have to use this block size 64/26. जहां पे आपको 30 तक का होस्ट चाहिए किसी सबनेट में. इस सबनेट में आपको यहाँ पे 30 चाहिए, यहाँ 20 चाहिए, यहाँ 16 चाहिए, यहाँ 2 चाहिए. उसी के अकॉर्डिंग आपको ये मैपिंग करनी पड़ेगी. ये एक टेबल से आप सीधे नोट करते जाओ. तो ये क्लास 3 के लिए एग्जांपल है. इन सम नेटवर्क यू वांट ओनली लेस देन 8 कंप्यूटर, 8 होस्ट. तो 8 होस्ट मीन यू हैव टू यूज द 14 ब्लॉक, ये वाला 16 वाला. इफ यू हैव ओनली 5 कंप्यूटर, तो you can use this block +29. तो ये ब्लॉक साइज है और ये आपका नंबर ऑफ होस्ट इस सबनेट मास्क के अकॉर्डिंग टोटल कितना होस्ट सपोर्टेड होगा वो ये। तो ये एक स्टैंडर्ड टेबल है और विद द हेल्प ऑफ दिस टेबल and this sheet, and this is a blank sheet where you have to identify how many number of hosts is required. तो ये आपको भरना पड़ेगा कि आपके पास कितने नेटवर्क है। सपोज ये एक नेटवर्क है, टोपोलॉजी है, जहाँ पे कहीं पे 14 होस्ट चाहिए, कहीं 20 चाहिए, यहाँ पे 2, ये भी 2, ये भी 2, ये भी 2 और यहाँ 6 चाहिए, यहाँ 30 चाहिए। तो इसको आप डिफरेंट नोमेनक्लेचर एज्यूम कर लें कि दिस इज नेटवर्क ए बी सी डी। इस तरह से आपके डिफरेंट नेटवर्क आइडेंटिफाई हो जाएंगे। नेटवर्क ए को कितना होस्ट चाहिए आप एक्चुअल होस्ट नोट कर लें, बी को कितना चाहिए, सी को कितना चाहिए, और फिर ये किस ब्लॉक साइज में फिट होगा ऊपर वाले टेबल से देख लें। अगर ए में 30 चाहिए तो 30 आप देखें, या तो बेस्ट फिट करना है तो इसको यूज कर लें। अगर आपको लगता है कि फ्यूचर में ये इंक्रीज हो सकता है तो आप 62 वाला ले लें। तो 30 लेने से आपका ब्लॉक साइज 32 वाला /27। तो यहाँ पे आपका सबनेट मास्क क्या होगा, /27। ए के लिए /27, जहाँ पे 8 रिक्वायर्ड होगा या 5 रिक्वायर्ड होगा वहाँ 6 वाला ले लिया /29। इस तरह से ये आप पूरा टेबल भर लेंगे। उसके बाद आपको इस ब्लॉक में फिट करना होता है कि किस रेंज से किस रेंज के एक कंटिन्यूअस रेंज आप निकालेंगे। तो बेसिकली होगा क्या, जब ये टेबल आपके पास तैयार हो जाएगा तो आपका एक रेंज आ जाएगा। वो आईपी एड्रेस कोई भी सबनेट आप क्लास सी का लेके चले या क्लास बी का, एक आप इसको जब आप इस पे नोट करेंगे तो आपको कुछ इस तरह का सिनेरियो मिलेगा। 10.32/27, 10.64/27, 10.104/30, 10.108/30। ये एक टेबल है जो भरा गया है as per requirement. Your actual requirement is this and it will fit into the block size of this, and accordingly there will be some subnet mask value in the form of decimal number, and you can use start from a IP address. So you can use the particular block like D can be fitted in this particular block. ये तो आपको यहाँ से उठाना पड़ेगा। तो आप देख सकते हैं कि कौन सा ब्लॉक कहाँ कहाँ पे फिट हो जा रहा है। तो इससे क्या होगा, आपको पूरा कंटिन्यूअस ब्लॉक मिल जाएगा। इट इज स्टार्टिंग फ्रॉम हियर एंड एंडिंग अप टू दिस। तो ये पूरा कंटिन्यूअस आईपी एड्रेस, और यही एक समराइज वर्जन हम इसको राउटिंग टेबल इसको कहीं भी ट्रांसमिट कर सकता है। सिमिलरली ये VLSM एग्जांपल 2 है। तो बेसिकली दिस एग्जांपल इज नॉट रिलेटेड विद आवर साइबर सिक्योरिटी, बट because subnet masking or this variable VLSM can be used by firewall, you have to specify accurate subnet mask. Then you must be aware with the subnet mask of a particular target. Now coming to public IP address and private IP address. So it is very important. So public IP address and private IP address. If you want to host some services, if you want to host your website in public domain means you want to publish your website on internet so that it will be visible to every user on the internet on the globe. So for this purpose, we have to configure our computer with public IP address. So this public IP address is visible on the globe. If your computer is configured with private IP address, your computer cannot send any packet to the outside network. Your ISP router or your public router will block the traffic coming from private IP address. So by default, private IP address is blocked by ISP. If this private IP address is configured at the user end or organization or some university or some corporate office. So normally private IP address is not supposed to send their traffic to the wide area network. There should be some mechanism that can translate their private IP address to public IP address. Then they will be able to transmit their traffic to the outside world. So there are two categories of IP address, public IP address and private IP address. And public IP address can uniquely identify a remote computer on legally can be identified because it is a unique identity of your organization, unique identity of your computer, because it is uniquely identifying your computer or resource on the entire globe. So with respect to different class A, class B, class C, there are some category range of public IP address defined by IANA, Internet Assigned Number Authority. So IP address is starting from 1 to 9 and 11 to 126. In class B, 128.0 to 172.15, then 172.32 to 191.265. These IP addresses are the public IP address of class B. This is public IP address of class A. So this is the range. In class C, 192.0.0 to 192.167.265. So this is the range of public IP address of class C. And apart from this public IP address, there are some IP address defined as a private IP address. In class A, only one network is provided as a private IP address. So we can use this private IP address in our network without any license, without any restriction. So IP address 10. So this is a single network. Remaining portion is used for computer. It is a host portion. So only one network is available in class A as a private or private use. For class B, total 16 network is available for using it as a private networking. 172.16 to 172.31. So this is first network. Second network is 172.17, 172.18. This will be the third, and last one is 172.31. Similarly, in class C, we have total 256 different network available in the form of private network, private IP address. 192.168.0 से लेकर 192.168.255 तक के जो भी डिफरेंट नेटवर्क आ रहे हैं, ये आप क्लास सी में होगा और आप इसको आप अपने कैंपस में यूज करें, अलग अलग नेटवर्क पे यूज करें, कोई इश्यू नहीं आएगा, बिकॉज दीज आर प्राइवेट आईपी एड्रेस. Public IP address need to be obtained from ISP or some agency who are providing the public IP address for our organization. तो क्लास ए आईपी एड्रेस में एक सिंगल क्लास ए का नेटवर्क मिलता है जिसका रेंज होता है 10.00 से लेकर 10.255. मतलब एक सिंगल नेटवर्क में कितने नंबर ऑफ कंप्यूटर आपको मिल जाते हैं प्राइवेट यूज के लिए? 16.8 मिलियन. सिमिलरली इन क्लास बी के एक सिंगल नेटवर्क में आपको हर एक क्लास बी के प्राइवेट नेटवर्क में आपको 65,534 कंप्यूटर आप यूज कर सकते हैं प्राइवेट नेटवर्क. तो दीज आर द रेंज ऑफ class C and class B and class A. So with this IP is visible on this screen is private or public, because it is starting with 180. We need to compare this 180 is falling in which range. 180 is not falling in the private IP. 180 is coming in this range, 172.32 to 191.2. So it is a class B public IP address. So it is class B IP address because class A IP address starts from 0 to 127, class B 128 to 191. So 180 is falling in class B and it is a public IP address. So this public IP address is allocated to some organization. So we can find out who is the owner of this IP address with the help of WHOIS services. So WHOIS services will be covered in upcoming slide. So coming to public IP address and private IP address, as a evidence, as a part of investigation by investigating officer or law enforcement agency, this public IP address is very useful because it is uniquely and legally identifying you. Whatever traffic is coming from the public IP address will be responsibility of the owner of this particular public IP address. Public IP address is also known as registered IP address, routable IP address, external IP address, legal IP address, non-reusable IP address, global IP address, or globally unique address. So these are the synonym terms for public IP address. Similarly, private IP address are non-routable because a packet from private IP address cannot be routed in the public network. Means इंटरनेट पे आप प्राइवेट IP एड्रेस का यूज करके ट्रैफिक नहीं भेज सकते हैं. 192.168.1.1 IP पे आपने सिस्टम को कॉन्फ़िगर किया और आप डायरेक्टली ISP के राउटर से कनेक्ट हो जाएं और बिना कोई ट्रांसलेशन मैकेनिज्म के आपकी ट्रैफिक नहीं अलाउ करेंगे. Internal IP because it is meaningful for internal network only, LAN network only, and private use only. Local, it is locally significant. It is reusable. So what is the meaning of reusable? अगर एक IP आपने क्लास A या B C का कोई भी प्राइवेट IP आप अपने लैपटॉप में अपने नेटवर्क ऑफिस नेटवर्क में कॉन्फ़िगर कर लिया, वही सेम IP मेरे गोरखपुर में भी मैं अपने सिस्टम में कॉन्फ़िगर कर लूंगा, तो देयर विल बी नो इश्यू अराइज, no conflict will be arise. Illegal होता है with this IP address, you cannot host your website, you cannot host your services on the internet. Unregistered, so this IP address is not registered. Private IP address is not registered to any individual or organization. But public IP address is registered to some organization, some individuals who have been allocated private public IP address. Now coming to types of IP address, there is one more category, static IP address and dynamic IP address. So static IP address means if you are configuring manual IP address on your system, it is known as static IP address. If you are configuring IP address with the help of DHCP server, dynamic host configuration protocol, then it will be treated as dynamic IP address. So static IP address is manually configured, manageable for a small network. It is normally not possible to configure static IP address in a large network having 500 computers, 200 computers. So very careful assignment is required to avoid the duplication in case of static IP address. तो IP conflict हो सकता है. एक ही IP दो सिस्टम पे गलती से पड़ सकता है. It can duplication conflict, IP conflict issue arise होगा. जब कोई एक IP दो कंप्यूटर पे आप ऐड कर देते हैं गलती से, तो इंटायर नेटवर्क अफेक्टेड हो जाता है. Dynamic IP address solve this type of problem because a DHCP server is responsible for assignment of IP address on the computer. Automatically, IP address is provided from the range of IP address provided by the administrator. तो आप जब DHCP कॉन्फ़िगर करेंगे तो वहां पे IP एड्रेस रेंज सर्वर पे देना होता है, सबनेट मास्क देना होता है, क्या प्रोवाइड करना है, वो सारी इंफॉर्मेशन आप DHCP सर्वर पे कॉन्फ़िगर करते हैं. So this DHCP server can be configured on Linux machine, Windows server machine, or your Wi-Fi access point, or any device which has option for DHCP server. So these IP addresses are actually provided for certain duration, which is known as lease period. So with the help of DHCP server, the assignment of IP address can be easily managed for a large network also. Duplication will be avoided. There will be no IP conflict because DHCP server will provide the IP address and DHCP server will note down each and every IP address assigned to which computer. So again, coming to public and private IP address. So basically, with the private IP address, you cannot be part of internet. At least one public IP address should be mapped with your private IP address. So and it is also not possible to assign public IP address for each and every computer in the organization. So if we have 500 computers, 500 public IP address cannot be assigned on all PCs. So there should be some mechanism which can allow private IP address to be connected to internet by using some translation method. So there are many types of mechanism which can map your private IP address to public IP address to private IP address. So it is normally known as network address translation, or with the help of some other translation service like proxy services, which can hide your internal IP address, but in the background they are mapping everything in their database and they are contacting to the outside world on your behalf. So whatever communication you are performing, the outside world will know you with the public IP address of your router public interface or proxy server public interface. सपोज यहाँ पे आपका ऑर्गेनाइजेशन है, कोई भी ऑफिस हो, इस ऑफिस में बहुत सारे पीसी आपको चल रहे हैं, यहाँ स्विच लगा हुआ है और ये स्विच से सारे पीसी कनेक्टेड है। सारे पे जो आईपी है वो 192.168.1.0/24 सीरीज में है। ये स्विच फर्दर राउटर से कनेक्टेड है और राउटर पे आउटसाइड इंटरफेस जो है वो पब्लिक आईपी एड्रेस है। This router can be your broadband modem, it can be your L3 router, it can be your server, प्रॉक्सी सर्वर भी हो सकता है। यहाँ तक जो आईपी होगी वो प्राइवेट होगी, वो 192 सीरीज का ही कोई आईपी होगा। सपोज 1.1 इसको हमने दे दिया। यहाँ पे कोई आईपी होगी जो पब्लिक होगी, वो चाहे आईएसपी प्रोवाइड करे डायनेमिकली या आपने स्टैटिकली इसमें असाइन किया है, जैसा आईएसपी ने आपको आईपी एड्रेस एलोकेट किया। तो इस तरह का कोई आईपी एड्रेस आपने इस पे दिया हुआ। तो आउटसाइड वर्ल्ड के जो भी कम्युनिकेशन होगा, इंटरनल से आउटगोइंग से इंटरनल, ये सब सारे इंटरनेट क्लाउड से जुड़े हुए हैं। यहाँ पे कोई वेब सर्वर है, इसको जो भी आईपी दिखेगी इस वेब सर्वर को, वो ये वाली आईपी ही विजिबल होगा। आपके कितने भी रिक्वेस्ट आए, ये 1000 कंप्यूटर की रिक्वेस्ट भी आ रही होगी, तो सारे कंप्यूटर की जो आइडेंटिटी होगी ये वाली। तो ये ट्रांसलेशन पब्लिक प्राइवेट ये प्रॉक्सी से भी हो सकता है। प्रॉक्सी सर्वर लाइनक्स या विंडोज पे इंस्टॉल कर लिया, प्रॉक्सी सर्वर भी यही काम करता है, ट्रांसलेशन का काम कर सकता है। नेट कर सकता है, राउटर पे नेट कॉन्फ़िगर कर सकते हैं। फायरवॉल में भी नेट का ऑप्शन होता है। तो फायरवॉल, तो ये अलग अलग मैकेनिज्म में। नाउ कमिंग टू स्पेशल रिजर्व आईपी एड्रेस। This special reserve IP address, so there are some few IP address, more IP address are available in the form of special IP address. So primarily we have public IP address and private IP address. Again, there are some special category of IP address. For example, 0.000/8. So this is a special IP address. It indicates current network. So in some of the routing protocol, 0.0.0.0 indicate current network, and for some of the routing protocol it indicates default route. So there are many address blocks are there. For example, 10.00/8. So it is a private class A IP address. Similarly, 100.64, it is looking like a public IP address, but it is not a public IP address, it is a private IP address. What is the use of this private IP address? It is the special range allowed by INR, and this category of IP address is especially used by communication between internet service provider. Basically, shared address space for communication between service provider and its subscriber when using a carrier grade NAT. So many ISP use this IP series for their internal NAT translation between their subscriber and their infrastructure. Similarly, 127, any IP address starting with 127 will be categorized under loopback IP address. It is a special IP address which indicates local host, loopback IP address. Then 169.254. So 169.254 is falling in this range, but it is not a public IP address. It is a class B IP address, but it is not a public IP address because it is a private IP address. 169.254 is a special series. So when this special series is used, it is a APIPA, automatic private IP address. इस रेंज को जो 169.254 की IP तभी allocate होती है when you have configured your machine as a DHCP client. आपने अपने NIC कार्ड में सिलेक्ट कर लिया है obtain IP address automatically, and there is no DHCP server present in the network. In that scenario, your computer will automatically configure with temporary IP address, which is known as automatic private IP addressing. APIPA, automatic private IP addressing. इसको लिखते हैं शॉर्ट में, ये तो लिखा ही हुआ IP block. So this APIPA is nothing but if you have configured your machine as a DHCP client. DHCP client में आपने सेट कर लिया ऑटोमेटिकली ऑप्शन IP एड्रेस ऑप्शन सेट कर रखा है, बट इन योर नेटवर्क देयर इज नो DHCP सर्वर अवेलेबल ड्यू टू एनी रीजन. कोई DHCP सर्वर ना होने की वजह से दिस machine will temporarily allocate themselves with APIPA range of IP address, which will always start with 169.254.xx.yy. So this series of IP address is known as APIPA. So APIPA is the special range of IP address. So again, it is a reserved IP address. Now 172.16, it is related to private network of class B. 192 is also related to private network of class B, class C, and there is one series of IP address 192.0.2.0/24. This series is normally used for documentation purpose. You cannot mention the IP address, public IP address of any company, any server on your in a public platform. Even as an example, you cannot use the public property of public IP address of the some server. So as a author, as a book author, if you are showing some example of network that this is a public web server, this is a private network. So even in the book or in the presentation at public forum, you cannot use the IP address of Google server or some public server. So for this types of scenario, you can use some sample public IP address or use for documentation purpose. So there are three IP address are available. This one 192.0.2.0, which can be used for documentation. And again, there is a series 203.0.113.0. This can be used for documentation. 198.51.100.0 can be also used for documentation point of view to represent some public web server in your presentation, in your e-book और किसी भी बुक में आप कोई सैंपल नेटवर्क बना रहे हैं, उसमें वेब सर्वर की पब्लिक IP दिखानी है तो आप रियल वाली नहीं दिखाएंगे, वो कॉपीराइट और बहुत सारे वायलेशन का वो इशू होता है. So these are the series, special series of reserved IP address, and in addition to that, 224. Any IP address starting with 224 is used for multicasting. 233.252.00. Again, it is used for documentation. 240 is used for internet. Internet means the INA people use this range for. It is a class E IP address. So these are the special reserved IP address.